This video contains sample clips from Operations with Variables, Part 3. Exponent of a base is a negative number. The expression means 1 over the base to the positive power of the exponent. If we have the expression 2 to the negative 3 power, Rule 24a says that this is equal to 1 over 2 to the positive 3 power. 2 to the negative 3 power is equal to what? Remember, an expression to a negative power is equal to 1 over the expression to the positive of the power.
Correct. 2 to the negative 3 power is equal to 1 over 2 to the third power.
The number factor in the numerator, the top number factor, can be divided by the bottom number factor, the number factor in the denominator. And that can be multiplied by the variable expression to the difference of the two powers, the first power minus the second power. And our final step is to simplify and write this as 4 times x to the third power. The first term over the term in the denominator, the bottom term, plus the second term in the top, in the numerator, over or divided by the term in the denominator. We can show that this is 4x to the fifth over 2x squared plus 6x to the fourth over 2x squared. 2x is the top of the fraction, our numerator. Y is our denominator, the bottom of the fraction. It's to be understood throughout the course of the problem that we may be working on with this expression that y can never represent the number 0. If we have an expression over another expression, a fraction, and we are adding to that fraction another fraction with an expression over the same denominator as the first fraction, the same bottom, then our rules explain that this can be written as the sum of the tops of the two fractions written over the common denominator, the denominator that is the same. Adding these two expressions with the same denominator results in what expression? Remember, you add the numerators and write them over the common denominator.
Good.
Left-click and drag the matching statement in List B to the correct statement in List A.
Good job.
Then we can rewrite that expression as the top of the first fraction, the numerator of the first fraction, minus the numerator of the second fraction, all over the common denominator, the common bottom. Left-click and drag the matching statement in List B to the correct statement in List A. If you need help, look at the examples on the slide.
Good.
To make the common denominator, we simply multiply the bottom of the first fraction times the bottom of the second fraction, and we've made a common denominator. So we multiply the bottom of the first fraction by the triangle expression, so as to keep the value of this fraction the same as the original fraction. We must multiply the top, the numerator of the fraction, by the same expression. Numerator of the first fraction, we can add that to the numerator, the top of the second fraction, and place that all over the common denominator. Operations with variables, Part 3.